Hey, hello and welcome to AWS Made Easy. This is the episode where we interview luminaries in AI and in cost optimization. Today, the pleasure of having in the AWS Made Easy studio my friend and colleague, David Hughes. David, welcome. Want to start, introduce yourself, and then want to go into how we met and the stuff that we were doing with Graph 10 years ago, more than 10 years ago.
At least 10 years ago. It's been a journey, hasn't it?
Yes.
Yeah, so my background is in graphs and thinking about more these days how they intersect with agents and agentic workflows and how we are rethinking what a model of data should be for agents and their ability to reason on them. But that's only where I am. And I think to Stephen's intro, it's part of a journey, and I think we're both still on it. I don't know that this is the destination quite yet. There's still plenty of road ahead.
Yeah, I have no idea what the destination is.
This is
Getting
true.
plugged into the matrix.
It could be that, or maybe we'll all be wearing Ready Player One headsets.
That'd be cool. I think we have a good history of introducing each other to technologies. You introduced me to that book. You said, you have to read this. I got the book. I think we've introduced each other to lots of technologies.
Mm-hmm.
We started at a medical research place. That's where you and I met. And we were doing some pretty cool stuff with graphs at the time. So if I remember right, we were looking at pathways, which is like a flow chart of, you get this diagnosis, you do this test. If this test is good, you do that test and take this medication. And it's basically just how you would write it down as a whiteboard if you were a doctor. Here's how this should get treated.
As a matter of fact, we made doctors our programmers because we said, given this clinical presentation for an oncology diagnosis, what is the standard of care for treating that? And inevitably, they'd get in front of a whiteboard and they'd start drawing circles and connect it, and you would do this, and there's this decision point. We'll call that a diamond. And what they didn't realize is they were writing the flow diagram and graph, that computation graph that we were trying to capture and tease the heuristics out of their head. They were our programmers, and we had the easy job at that point, or so we thought.
Well, so I think what we were working on was basically on number one, it was a compiler for this language in the sense that, okay, say if you had a doctor who said, if this test result is above 10, do this, or below 5, do that. What happens if you're a 7, right? So our compiler should check for exhaustiveness. And the other thing is, okay, so say you have this test and it's compiled, then where does this particular appointment fit in to their graph? I think that's the kind of problems we were looking at.
Right. We were trying to design both a DSL and a compiler around the computation of clinical care.
Yeah. So that was where we met about 10 years ago. I think you've basically been in graph since then.
I have been. I haven't left. Yeah. Maybe there's been some things that have come into that, but absolutely.
So graph.
Yeah.
So you've been in graph. What other graph problems have you worked in over the years?
Well, since you and I were struggling with trying to come up with this computation model for clinical care, that has continued into domains like cybercrime, logistics, supply chain, but all of these things that take into account that the world is, since 10 years ago, continue to become more connected. And as a corollary, so is our data. So the way to think about that is through connected data. Graphs the implementation of connected data, but I really think fundamentally the conversation shouldn't be about graphs and databases. It really should be about the connections in our data.
Got it. Okay, connected data, connected graphs. So we used to worry a lot about ontologies, and we would have to download these big databases from medical things, and they would say, okay, you have this class of like the diagnostics, right? We have this code.
ICD-10.
Yes, and that code has subcodes and it has subcodes.
Yeah.
And we'd have to write parsers for this stuff and figure out a way to load this all up. Where else do we think in these kind of ontologies and data relationships, like where does that come into play when you're explaining that to a normal person? Like, why is this better than relational databases?
Sure. So In the world that we were in 10 years ago, we, I think, had the foresight to know that we needed some understanding of the data beyond the instances. I have this apple in front of me, but we needed to be able to think in abstractions of fruit. What fruit do I have available? So this is similar to this ICD-10 diagnoses. We knew that we had a diagnosis in front of us of congestive heart failure, but we needed to also think about other patients who had heart disease. And the only way to do that is if you have some higher abstractions or ways of thinking about your data. And that was the foresight I think that we had. Today, I have I think the unique privilege of having landed in a company that is their focus, is semantics and that semantic layer. And what it allows us to do is to think about our data in these higher levels of abstractions, not just this is a that is a that in the sense of a taxonomy, but what are the definitions and meanings of those concepts as they connect to each other.
Well, it's funny that these definitions, it's about similarity, which is really, really a tricky problem, right? It was tricky in medical when we were thinking about, are these two patients similar? Like, well, that depends on what you're asking, right? If it's in the context of particular disease, then maybe their age might be relevant, it might not be. And I think about, with cars, right? If you are a gearhead, then you might think, okay, the Corvette and the some other muscle car, sports car are very similar. But maybe if you're a kid, you think that similar cars are just based on color. And if you have a red Corvette and a blue Charger, well, these are totally different. They have nothing to do with each other. Whereas maybe you group them differently if you were comparing them in different contexts.
And that's the key, is context. Ontologies, taxonomies, and even graphs, they give you the understanding of what things are and how they relate to each other and how they are ordered or sequenced. But it's through the lens of the user or the agent in this world of agents. Context is what's really important. And I think that is a challenge that we're still coming up with the best ways to implement that today.
Got it. Okay. So today we have RAG. What is RAG?
Great. Well, it goes back to your statement about similarity. It's about similarity. So if we want to give a model context or some knowledge of a question and a domain that question is in, we have to give it access to data. And models can't take the world of knowledge. They only have so much memory. And that's expanding more and more these days, but it's still constrained. So we have to give models the ability to look at information that is relevant to the task and to the user's question. The way we do that is through retrieval augmented generation. We can take a big document, we can break it up into smaller pieces, we can create an embedding for that knowledge or that text, and an embedding is just a mathematical representation of text or images or audio these days. And we can store those embeddings in a special kind of database that allows us to search for that information based on similarity.
So what do you say if you have a picture of a juicy red apple?
Yes.
Then that has a similar embedding to the statement, this is a juicy red apple. That part I get intellectually, and it still breaks my head that actually works. But I get it. It's the coolest thing that actually works.
Well, it works for a reason. So one of the more popular models for doing what you just talked about is a model called CLIP from OpenAI. And CLIP allows you to take an image and a actual vision model, which has been trained on features of images, colors, the actual contrast, textures, etc. It's been pre-trained on understanding these features of images. Now, another model for the caption, this is a big juicy red apple, that has also been pre-trained on understanding words and how they relate to each other in sentences in bigger parts of a text, like a paragraph or a document. A popular model for that is BERT. You can combine both of the mathematical representations for the way those models store their information. Those are called embeddings. And you can put that into a special vector database. LanceDB is a popular one for an embedded vector database. And you can then perform a similarity search to the question of, I'm looking for fruit that is juicy and red. I didn't mention the word apple, but because the words juicy and red are similar to how you stored your picture of the juicy red apple, you might find that image. Now, that's just the clear-cut case. There's a lot more capability there, and maybe we can get into that in a little
Yes.
bit.
Okay, let's do that.
And GraphRAG, because right now we're just talking RAG, vectors. We're not even talking graph yet. And we haven't decided what the problem is with RAG. Our challenge, not problem. A limitation.
Okay, get this all set up. This always takes me a second. Okay, I just need to get power and I'm set.
In a feed, right? Or unless it's Bluetooth.
Power and I'll just store it locally.
Oh.
Where the hell is my? There it is. Is everybody working today?
No, she's starting to get, so she got a promotion. She's a director at the museum now. And so she's starting to get weekends off.
Oh,
So this is why I'm trying to spend more of my weekends with her, because I actually can.
Okay. These.
If you ever leave CloudFix, we need to start a regular podcast together.
Yes.
But right now, I know you're in service of CloudFix. But if that ever changes, I would love to start doing these like weekly.
Hard drive.
Do you think that's ever changing in the near future, or probably not, because you need stability right now?
Yeah, no, I like it. I'm good at it. Pays good, so I'm not going to change anything. And yeah, that would be the last. Unfortunately, yeah, it's the last thing I want to change at the moment.
Yeah.
But we could do a regular podcast. There's nothing stopping me. It's just.
Well, there's conflict of interest for you. You always have to then be careful that you're not.
I don't think so, because as long as, I mean, like, if it was too far not related, I just wouldn't bill for the time. But otherwise, I mean, they want to be AI thought leaders.
Okay.
So anything that gets us to AI thought leadership is a win. If it was a sports podcast, I'd have a problem with it.
Well, if you were doing it on their dime, yeah.
Exactly. But they're great. Okay, I need to find my.
We're looking forward to help.
I have a USB hard disk. I think it's in that little box down there. Get it in here. Okay, so we've talked about RAG. Now, what is GraphRAG?
Well, one of the limitations or challenges in standard RAG is that when you ask a vector database to give you back some results that are similar to your query or your question, you only get back a certain number of results. Typically, that's called top K, and you get something like a top K of 5 or 10 of the most similar things to your result. Now, what happens if the 11th thing is also interesting and could also provide some context and information to your model that would be useful? Well, GraphRAG takes those results from, let's just say, the top 5 that are the most interesting, and uses those as what's called anchors, or starting points in a graph query. And you can think of it as an analogy of saying, A vector query or search is local. So show me the things that are local to my question. And in a graph, take the results and use those for a more global understanding of my question. So I can now run a graph query and say, given these starting points, help me explore the space of what I want to know a little bit more.
Okay, so classic graph would be a social network. So they take LinkedIn.
Mm-hmm.
So give me an example of something that a GraphRAG query would answer better than a RAG query.
Sure. Let's say in my vector database, I had some mathematical representation, these embeddings of people and skills that they have. And I said that my query to the vector database is I'm looking for people who know a great programming language, and specifically one that was memory safe. So let's just say memory safe
Rust.
languages
Okay.
and people. Yeah, so like Rust. Certainly not Python. What you would get back is maybe 5 results that are of people who know memory safe languages. But you don't know that a priori. You just know that it's similar to the question that you asked. I'm looking for people who know memory safe languages. I'm going to get back from that as metadata the IDs of my nodes in a graph for those results. And those IDs might be people. So I have some nodes of type person in my graph. I can now write a graph query that then expands that and says, these are people. I want to know other people who know memory safe languages.
Okay.
And I'm going to start to get back actual data of maybe I'm going to get back Steven. I'm going to get someone like an Elliot and a David and a
Darko is going to show up and he's become a Rust
yeah.
guy. Okay, and then all our old Haskell buddies.
Right, but
Okay.
then the other thing from that graph query is I'm going to get back what were the languages that were memory safe. So not only am I going to get Rust, but I might get back Go or some other languages. Now I have actual data that I can give my language model and say, answer my question. And it's going to come back and say, oh, you are interested in memory safe languages? You should take a look at Rust and Go. And by the way, Darko and Elliot, they can really help you understand Rust and Go.
Okay, so it is doing a query. Okay, so if I search for friends who know memory safe languages, standard vector database is going to look for other things that are similar to memory safe.
Mm-hmm.
Now it's still an LLM, so I'm still going to get that context of, okay, Rust is memory safe. But you're saying that a GraphRAG is going to somehow anchor on the top couple of results, which in my case would be my friends who are really into Rust and Haskell, and then being able to somehow query the underlying graph engine.
Right, and provide you with global evidence for the results.
Okay.
So a really concrete example outside of the social networking question was recently I built something called multimodal GraphRAG. You can take an image and you can break it down into its components. So what are the objects in the image? How are they related to each other? You know, this is left of the banana is left of a cup, and the cup is below a TV screen. And things like textures and colors and predominance, and is this a picture of a banana or a picture that has a banana in it? And it uses all sorts of things like bounding boxes to figure all that out. If I ask for pictures that have bananas of a vector database, I'm going to get back pictures that are similar that have bananas in them. Mm-hmm. But I'm only going to get back these images, kind of like if I did a Google search and I typed in images with bananas. I don't have any interpretability or understanding of why I'm getting these images back other than some assertion that they're somehow similar. If I then take that to a graph that I've stored all of those components of the images and how the spatial analytics are related to each other, I now can run a query in that graph database and get back all that information, including descriptions, what objects are in the image, colors, and everything else. And now the language model has something to reason on. And so not only can it say, like Google, here's the top 5 most similar images, but now a language model can say, looking at the graph structure of these images, I can now tell you that these are 5 similar images, but these 2, they're really better because you asked about pictures that had bananas on a wooden table. And while all of these do include a wooden table and do include bananas, these really are of bananas nicely placed on a table. They have the same scene. And oh, by the way, here's some other images you might want to look at that even though they don't have bananas in them, the composition, the same colors, and the same kind of predominance of the scene are similar.
Okay, all right, I understand. So it's part of it is how you processed it when you were actually intaking the images and you were running it through an understanding that's actually saying, okay, this banana is on a table, this is in a home setting, this is in a bowl or on a cutting board, and that way you're not going to get a grocery store fruit aisle that has a banana in it, because that's not what unless you were looking for that. And so you would have some approach of actually storing all of the physical relationships, like banana on table, table on floor, floor in kitchen, something like that.
In the predominant color of each object. So you are able to do additional analytics in that pre-processing where you can say, what's the complexity of an image? How many edges does it have in it? For each object, what is the top 3 most predominant colors? And if you think about a square or a rectangle or some 4-sided bounding box around each of the objects, you can look at the dimensions of those compared to the overall image and say that the majority of this image is taken up by the banana. So this is a picture of bananas versus it's only a small portion of the image. And now I can say it's a picture that has bananas in it. I'm not going to get that kind of latent, rich signal from a vector, but I am going to get that from a graph database. I think most people think about GraphRAG as a way of going from this local to a global search and expanding the context that you give a model. I think that's very true and is one of the first recognized benefits of using graphs and GraphRAG. I think the next level for me, though, is this explainability that you can get from using GraphRAG that you're not going to get from just doing standard vectors. But they require each other. It's a marriage.
Okay, so then in an enterprise setting, when you've got the typical big enterprise has got some giant SharePoint server somewhere, and they've got probably a bunch of code repositories, and then they say, okay, we want to have an internal AI search or internal AI agents that have GraphRAG. So what would be the steps you have to do to prepare that data? Because it seems like you can't just dump it in.
No. And there's so much nuances that I think a lot of organizations struggle with their explorations into using agents, into using RAG and GraphRAG, because many of them will jump into the details of, okay, how do I chunk up these documents and make sure that my chunks have overlap? And what am I doing to ensure that I'm managing context appropriately? And what kind of embedding models are we using? And they'll go into those kind of details. And all of those are important in your strategy for how you're implementing agentic RAG and GraphRAG. Where many organizations and teams struggle is they didn't start off at the very beginning of where you're going to get the most boost in your performance and in your quality of results, and that is providing agents in the entire workflow with semantics, ontologies, and having that structure before you start dealing with the workflow of managing the data.
Okay, so here's a question that a lot of companies face that I think GraphRAG could help with as an example. So say you have a salesperson and they have multiple, a lot of salespeople that they have to cultivate relationships. And so they have multiple relationships that are in various stages. Sometimes you have salespeople like any other employee, they leave the company, they go somewhere else. And so you have their inbox and their CRM. Often the CRM is out of date. Yep. And so you want to say, okay, well, based on their inbox, what was the status of our conversation with this company? Are they warm? Are they cold? Who's
Right.
our allies? Who's the skeptics? What is the status? So how would you prepare a GraphRAG system to help me answer that kind of question?
Well, first I would start off with the semantics of what is a lead? What are opportunities? And what are the categories of opportunities? But once I had all of that in place, then I would make sure that to start to really ask the intent here. It's not just to capture history in your use case. I think it's also how do we tease out the heuristics that are in a person's mind so that if that person leaves the company, it's not just the history of what was in their inbox, but it's also their history of how to work with clients and how to convert a lead into an actual engagement. So the ontology of understanding that domain would be where I would start. Then I would start to worry about taking a connection or an interface to the email system that my enterprise is using. How best do I take that data out? And how do I make it readable to an agent? I'm not going to give it just a bunch of text. Often models do a better job with Markdown, for example. And there's lots of nuance and details in how you go about that strategy.
Okay, so I'm trying to think of some use case. Okay, say we have this horrible thing, sales team gets hit by a bus, you need a new sales team, and you have to go over everyone's email and say, okay, what is the status of every deal? So you would then say, okay, so you take the previous sales team's G Suite data, load it up. What would your thoughts? What would your discovery process look like?
Sure. Back to semantics, but once I had a model of what I'm looking for, so I'm looking for company names, technical lead, sales lead, these concepts that I want to know from each email. I also want a category of emails because there's going to be all sorts of emails in the deceased, unfortunately, sales team. They're going to have ads, they're going to have personal emails. So I have to have some way of categorizing. Is this a sales related email or not? So there's a taxonomy to what I'm interested in. And once I have the right kind of email, then I want to know the features, like I said, organization, technical lead, sales lead, whatever. I think the challenge right now is a lot of approaches rely on a language model to figure out and to pull out these entities of organization, for example. What I think has happened in the last 6 months or so is a more deterministic approach to having output come from a model that is reliable and that you can reason on and you can test. And what I'm talking about here is a company named Boundary ML developed something called BAML, B-A-M-L, basically a made up language. And it allows for you to deterministically create types and define structure and then expect a model to actually give you the result and the structure you want versus what has been the history of how we did this, which was prompt engineering, which is effectively being a code whisperer and really good at begging the model to give you what you want.
So I've tried, I've tried kind of similar approaches. I think you look at the naive approach, and it's okay. Well, you can put whatever you want to this knowledge base, and you'll get something out. Mm-hmm. It's okay. Convert all these emails to text, dump them into an S3 bucket, point Bedrock knowledge bases at it. But you'd be surprised at how not great it is, because, like you said, it doesn't know that Debbie at such and such is Deborah at the parent company.
Entity resolution.
Yeah, it's very, very coarse. Mm-hmm. And you think within the email, within someone's entire inbox, you're totally right. There's thousands and thousands of messages. There's meeting requests and meeting reschedules and a lot of noise that if you just naively dump all these emails as a bucket of text, it's not great. Mm-hmm. So then you could use something like BAML to say, who are the people in this email?
Once you find the right email, it's really an agentic workflow. You first have to have an agent that says, is this an email I should even try and parse?
Because it might be a sale. It might be a
calendar invite.
A calendar invite. It might be spam from someone who has a similar name.
Right. Or it just might be an email, like you said, us buy our new widget or consume our new service. And so you have to have upstream agents that are helping you first identify emails that are of the category of interest. And this is true of any agentic workflows, is there's many upstream tasks. And I think of tasks as being something that are atomic. And typically you want an agent that is using a language model that is very good and has affinity for that task.
Yeah, okay. So just converting all these emails into text, dumping them in an S3 bucket, not going to give you, we're not there yet in terms of having the LLM just take a bunch of emails.
Right.
I tried that. I tried the naive approach. And even things like, what is the status of this? It would require, within the internals of the LLM, sorting by date and watching the trajectory of this conversation evolve over time. And I don't think it's there yet. I don't think there's enough internal smarts to do that yet without, like you said, some mechanism of adding that structure at parse time. So you do some pass of the emails to load this up into a graph database. Okay, speaking of graph databases, we are all, I think, maybe a pro and a con of people of our persuasions. We like to nerd out on the tools a lot. What is your graph database of choice?
Oh, that's a loaded question.
Sponsored by.
Sponsored by, yeah. No, I would say it often is use case dependent, but where my mind goes more these days and I gravitate towards is embedded systems. I think that the opportunity to not have to have and suffer the IO of going out of process and then back into process is where I focus these days. So when I'm thinking of a graph database, I'm more often than not, I'm looking at KuzuDB. When I'm thinking of a vector database, I use LAMPS. Between those two, I can orchestrate almost any solution that I need using some orchestration tools. These days for orchestration, I tend to think of a service called donu.io. But between all of these things, I can operate without much I/O.
Okay, so you're trying to think, how do you stay in memory on one machine versus...
Or container.
Yeah. Well, that makes sense, because if you are... Right, it's very easy to reach for an external service and say, okay, I get this API key, I pay my $20 a month, and okay, I can do this. But it's often, people don't realize at this scale, it's like orders of magnitude slower than just staying local if you can.
And there's cost. So the other thing I see a lot of teams do is they will build an agentic solution and they'll go to OpenAI, Anthropic, or some Gemma 3B is in 3.2 12B is incredible. But often these are models that are general purpose and good at a lot of things. Where I think we'll find more performance in both compute and speed, and then also in quality, is breaking down problems into their component pieces, their most atomic component pieces. The CEO of Boundary ML, Vaibhav, who they make BAML, has hammered this lesson into me, and I'm thankful for it. And that is breaking down tasks into their most atomic pieces means that we can now start to run local models. We don't have to also go to the IO of calling some external service, and we can run them to the smallest parametered model that is task affinity for what we're trying to do. So that intent classifier of, is this a sales email or not? We don't have to ask a large, trillion parameter model for that. We can ask a little 3 billion parameter.
So you can ask Olama.
Absolutely.
Olama was 8.
Five. We can ask 5.4, which is a 7 from Microsoft. It's a 7 billion parameter model. We can ask it that question running locally in a container. We don't need to go out to a trillion parameter model to ask it this very simple question.
Okay, so often, and again, we're AWS made easy. People say, okay, we do everything AWS native first. At the same time, because you want to run a local model, It's not that you're somehow like anti-cloud or
No,
cloud
not at all.
skeptic or
My
whatever.
container's running on AWS on an EC2.
But you're saying you want to do
Or
this
Fargate.
rather than a managed service
Right.
for speed.
Mhm.
And because you don't need, if you're going through a million emails that are all 2 paragraphs, once you strip out the obnoxious signature and the quote and the, book my calendar, once you get rid of the cruft, it's actually like 2 paragraphs of context. You can have a quick model that runs on the same CPU and the same RAM. Is this something I should process further or not?
Mhm.
And for that, you don't need to call out to any external API. And as fast as it is, just doing it on the actual same machine, same chip is just going to be faster.
And you get portability for this. If I'm running this in a Fargate container, and I now want to share this with someone else who has an AWS account, I can do this because I now have a container. I can put it up into a registry. They can then pull it down, and they have the same capability without me having to go and recreate this in their account. Additionally, you can start to think about this when you're working with smaller atomic, low parameter models. I can even include that as a layer to a Lambda running in AWS and now start to think about serverless agentic workflows.
Okay, but then zooming out for a second. So when is it time to use the big models? Right? When do you reach for your Llama 405 or 3.7 Sonnet? How do you know when a model is good enough for your task? What's your decision criteria on which model to use and how big of a model to use?
It's an ablation study for me, and I think it should be for most teams. Start with, do I need reasoning and do I need multimodal capabilities? If so, you're generally going to be looking at these larger foundation models. But even there, you can start there and then start to ablate back to smaller parameter models and monitor and come up with a grading metrics, some optimization function of, am I still getting the performance that I need? For example, you can use a very large multimodal model to evaluate an image and then start to ablate back to smaller and smaller models. And you might find that something like Lava, which is a 7 billion small parameter model, that you can still get quality image analysis and decomposition, like we were talking about objects and segmentation in an image. You can achieve that with a much smaller model. If I needed chain of thought, reasoning, and understanding and describe your steps along the way, you might go back up to a larger model. The trick, though, is to come up with a framework that you're going to use that allows you to test and iterate and adapt quickly, because models are changing at such a meteoric pace that you can't rely on things like prompt engineering because they're very brittle. It is unique to each model that you're using. So you need a system that allows you to say, for this task, I want to try this model, and up into the point of next week when this other model comes out and is better.
Okay, so you swap the model and swap the prompts very quickly and being able to have your general flow be one thing, but then switching the models and switching the prompts within that.
And this is where something like BAML, and I don't mean to sound like a broken record here, has taken a very novel and I think a very disruptive approach. Is instead of prompt engineering and being able to swap out the models quickly, which you can do in BAML, they've taken the approach that the prompt is the function. So you can actually put logic, you can put structure and branching logic right into your prompt. So now you don't have to do so much prompt engineering as much as have conciseness in the description of your task and rely on things like actual programmatic structures like structs and types.
Okay, I'm definitely going to have to try. I think you showed me some BAML once, but we all have 1,000 things going on, so I didn't dig into it. I do like using, on the Amazon side, using Converse, because then you can switch model IDs very quickly.
Mm-hmm.
And it's, as a solo developer on a personal project, whether it's 5 cents or 50 cents or $5, it kind of doesn't matter. But if it's 500,000 versus 5 million versus 50 million, it really does. And to being able to, my go-to model would be 3.7 Sonnet,
Okay.
and at an individual level, yeah, who cares, right? Oh no, you hit $5, but like I said, if you could pair that back by an order or two of magnitude, and I've been trying to do that. What happens if I switch this to Nova Light or Haiku or any of the smaller models? And in a lot of cases, that's perfectly fine. And then being able to
And performance
yeah,
improves, speed.
exactly. And again, on my personal projects, doesn't matter. I'm characterizing 100 things. What does it matter? But when you get to these huge orders of magnitude, obviously it starts to matter a lot. And that's where we have to, like you said, I guess, build in mechanisms for being able to swap the model, whether that's using BAML or Converse, to modify the prompt, to be able to judge, is your results good enough, right? Because you want to get the cheapest, fastest model that gives you good results.
And then there's all the infrastructure around these concepts. So if we expand out the ability to swap your prompt or tune your prompt and change your models, that goes into where I think we're heading in the future. And that is having orchestration systems that allow us to monitor the performance of an agent, to look at how it's managing its memory, how is it compressing and updating its observed facts from previous conversation or long running context, and how are we then injecting back into that whole workflow things of like the nature of, let's tune the prompt and dynamically let's do this at runtime. We see that the performance of this model on this particular atomic task is degrading. So it's time to maybe change out the model it's using. If we see that the pattern that we're using in the entirety of our orchestration, so let's say we're using a teacher-student pattern, maybe we need to break this out into a supervisor-team pattern because the student-teacher pattern of agents isn't working. But you have to have an orchestration system around that to be able to do that.
It's funny how we like anthropomorphize these things, but it's not a bad way of thinking about it. And like, there are times where, I've got my system, I'm using Cursor, I'm using Claude, and I don't want to say Claude is misbehaving because that doesn't seem like the right word, but I was thinking it is off today. Like there's something about why can't it just nail down the stupid Lambda function, right? And there's sometimes the system has, for lack of a better word, off days, and I don't know exactly what drives that. And it is getting to the point in the complexity space where maybe that is the best way to think about it. It's just having an off day, and you have to be able to pin it down to figure out what it is. And like the thing that we just debugged just before this session, right? We had a difference in a version of UV that was making a difference somehow. All right, let's take a quick break. When we come back, let's talk about what your thoughts are on MCP, some of the coolest projects that you've built that you can talk about. You can anonymize the details, and where do you think things are going?
Sounds good.
Cool. All right. So we're back. So MCP, that is all of the rage right now. And we experimented with tool usage first came out. We built out some cool stuff. But MCP seems to simplify tool usage. Or what are your thoughts on MCP? Does it deserve the hype or not?
I think it deserves, as someone recently said, a friend of mine, Nurain, it deserves the promise.
Okay.
I think MCP presents a promise of the art of the possible and of a glorious future if it comes to fruition. It's not there yet. There's challenges in the protocol. There's great features in the protocol, but there are challenges, and we'll need to see how that consolidates and how it converges on a standard. So right now, I think it's a wait and see, but it's exciting. I think that I initially was not very warm or receptive to the concept because my question that I struggled with, and frankly I still do, is how is MCP different than APIs. What am I getting in MPC or MCP that I'm not already able to engineer and achieve with an API? Now, I think I have some understanding of that better now, but I still struggle with where are we in being able to deploy MCPs more than just as local niceties or interfaces to tools and services.
And certainly, yeah, we're still figuring out the authentication part. A lot of MCP delivery is here is a local Python function which calls a remote API in the back end, and the credentials are baked in outside of the system.
Right.
Like a Docker container that you can set an environment variable and then run. I don't think it's industrial strength in terms of authentication yet. We're working on it. Now, as an asterisk, there's a thing that we're kind of related with called MCP Hive, which you can take an API that has an open API spec, hand it to MCP Hive, and it will give you back a URL that's a valid MCP server based on the open API spec, and it'll use SSE transport. But we're still, I'm not sure where it is in the complicated auth schemes yet. So I agree with you that part is still it's still tricky.
Right. And that's the thing is that are you better off giving an agent access to a browser that the agent can then use to go and look at an API by calling a Swagger or an open API call and say, I want to discover? Or do you a priori define that in an MCP service? Security is a challenge. I think that there is some interesting approaches to how to solve that. That tends to be right now locally. How do we handle that when an MCP server is running remotely? And that, I think, increases in complexity when we start thinking about multi-tenancy on MCP servers running remotely, where they have to manage session of authentication and authorization across many different users or agents coming in to use that server. But there's some other complexities that what we can get into.
What I'm excited about, so there's a product that I've been working on for internal usage, and I spent a bit of time building out a front end for it, and I'm not good at that. I don't like front end work. And then when MCP came out, it's actually my project over the last few days has been MCPifying this whole thing, which basically comes down to MCP tool wrappers around all the back end. And so what I realized is you can actually just write a back end and, whatever AI front end, whether it's Claude Desktop or we have one called F4, whatever that is, that can be your front end. And your users can literally design their own front end on the fly. And obviously it wouldn't work for a game, but for a corporate CRUD app where you are saying, I have API that takes in this, it does some stuff on the back end, and it makes that. Well, anyone could just design their own interface on the fly, saying with Claude Desktop or F4 or whatever they want, where it's mostly just filtering pagination, relating data together, moving it from this to there. So I'm really happy with that because it simplified my life a lot. I tried tool usage when that first came out with OpenAI, and that was a little bit more brittle. Like you have to have this. Actually, I tried it with both Bedrock agents and OpenAI. OpenAI is more flexible, but you still have to make these Open API /Swagger files. I think MCP is a little bit more discoverable than that, because part of the MCP protocol is list your tools, list your capabilities. And I think what I'm most excited about MCP is that your LLM becomes the glue between all of your tools. And so if you have if you have your email, which does this, and your to-do list, which does that, you don't have to write that integration yourself. You just say, I'm going to give both my email and my to-do list access to Claude and just say, okay, look at my last 10 emails, and if there's any to-do lists, dump them there.
So there's some complexity to that, and you're right. It's exciting times, and you're able to quickly orchestrate something a little bit more nuanced without some of the engineering that was necessary in basic vanilla tool usage. Even though I think that had you tried out BAML's way of types for tool routing, you may have been a little bit happier. But to MCP, you said two things that were interesting. First, I think the one that is unsolved, at least remotely, but I think that there's a lot of good work happening on some companies that are going to be coming up with some things very shortly, and that is discoverability. Locally, having an MCP server with multiple tools or services, yes, agents are able to query that service and figure out what's available and to do some tool routing. Remotely, that's going to be a little bit harder because now you have to discover what is possible out there as far as MCP servers. And I think concepts like MCP Run, if you haven't heard of them, take a look at them. They are essentially an MCP server registry. Those kinds of solutions, I think, are going to open up a lot of possibilities. Challenges as well. How do you, just like NPM, PyPy, Cargo, or crates.io, how do you trust the MCP servers that someone is registering on one of these discoverable services? Then there's the whole concept of how do you safely and securely use credentials through these services if they are not accepting the cost themselves, that they are going to pass that on to you. That means you need to pass back to them some kind of concept of a token or a credential.
And then what happens if you have, like you said, you have a weather MCP server, which puts a task in your to-do list to transfer money to this account. Mm-hmm. And then you have some to-do list processor that actually does that. And for whatever reason, you've hooked up your Venmo to your MCP, and all of a sudden your weather is telling you to transfer money to this bank account on the off chance that it might work.
Right. Now, so yeah, that's the discoverable concept. I think the other two things that I pause on, one is compound actions. Right now, MCP works really well when it's an atomic task. Get me the weather. I want to have my agent have the ability to call an MCP server, discover what tools are in there that can help me understand and retrieve weather, and then call that tool and then bring that information back to my agent. Well, what happens if it is, an example I saw recently was email. I want to send an email and I want to call an MCP server to then find out which tools or services it has that can help me send an email. But really, I didn't want it to send the email. I wanted it to first draft an email. I then want to look at that draft. I want to iterate on that draft. And then I want to then send the email. MCP servers are not good with sequential steps of actions. They're singularity processors at the moment.
I know the MCP has the concept of a prompt where you can say, what prompt templates does this MCP server support? Mm-hmm. So you can, but I mean, even when I'm using Claude Desktop. So an example I had the other day where I was saying clean up, I typed in, I run Cursor in YOLO mode with agents. So I'm aware of the fact that it can do destructive things. I said, okay, clean up this Git repository. And it added an MIT license and then committed. I said, oh, great, my code's open source now.
That's right.
And I couldn't, it was incredible. And it literally not only added the license file, but then it Git committed that file and pushed. Yeah. Which isn't something I intended it to do. I don't care for this particular project, but I could see how you wouldn't necessarily want that on every project you were working on. Mm-hmm. To have it.
But MCP is going to have to support those kind of compound tasks in order to be more than just able to do singular things. Otherwise, all of that engineering still has to be accomplished somewhere. And that'll bring us to a point that we'll go to in a second. Here's a question, though, for you before we go into this concept of where should the onerous of engineering be in the MCP client server paradigm? But before we get there, here's a question for you. Have you heard about or discovered in the protocol something called sampling?
Yes, but I'm not sure what its purpose is yet.
Okay. Well, I recently discovered this in a conversation with some friends because I didn't know about what sampling was. And I'm just getting more into the depths of the protocol as Anthropic has described it. And now it's being evolved by others because there's so many people in the MCP race now. Sampling is a very interesting feature. As I understand it, imagine your client, an agent or your client, makes a request to an MCP server. Because MCP is a bidirectional protocol, the MCP server can now prompt back to the agent and ask it to generate. And now it can use that as part of the context of how it's going back and forth to service this request.
That's right. Okay, I did read about this once. Okay, so the MCP server can ask for more information.
Or to perform some generation. So to me, that is interesting given the world that I think you and I come from, which is the days of APIs. When you made a request for an API, it was one way, and then you got some information
Yeah,
back.
you're never going to hand extra information to the server without it being in your control.
Well, and that's right. But imagine if the server could then even ask your system to, hey, do some work for me, and then I will process the rest of your request. And that work, to me, is still, I think, exciting. What you could do with something like that, but also just some area to be thoughtful about.
And that's I think what I struggle with, like on my daily workflow. The stuff that I'm working with right now, personal products, not that high stakes. I'd rather use Cursor in YOLO mode, but there's times where I can't rein it in. Like I'll tell it, do not deploy under any circumstances. Just change the code, and it will still try to deploy an Amazon task, and we'll start creating test scripts. And so I have Cursor rules to try to rein it in and say, do not create test scripts. Just modify the existing ones. But how to rein in AI agents while still giving them enough power to be useful, that's tricky, right? Because everyone knows what we mean, but it's really hard to kind of elucidate it and say, okay, I want you to be able to make stuff and delete files, but don't delete these files. I want you to run scripts, but don't run the rm command, or don't run rm-rf ever.
Come on, you only live once.
And sometimes it does not listen. Like I'll say, use this script to deploy.
Right.
We're getting there. I found myself arguing with them a bit,
and that's where I think some of the conversation I've been having lately around MCP is intriguing, and I'm not sure where it's going to go. But that is this concept of right now, if you think about the frameworks for developing agents and even trying to orchestrate them, it has become fairly fragmented around what framework are you as a developer going to use. Are you going to use LangChain, LangGraph, Llama Index, Crew.io? Are you going to use some of these more elegant approaches like Dunu.io? Or how are you going to manage long-running operations? Are you going to use Restate? You have to have, I think, a lot of knowledge to pick a solution that makes sense and that isn't going to bog you down with a lot of overhead. So in MCP, we're starting to see that same environment potentially evolve. We have MCP from Anthropic. Great idea, kind of an abstraction on top of APIs. But now you see Dapper from Microsoft, which is was always a microservice orchestration brokering concept, but now they've gotten into AI agents. Just released a new announcement about that. Google has a new concept around MCP adjacent technology.
Oh, interesting.
And so it's beginning to fragment. And the challenge will be this: which version of MCP and the standard and how it's being implemented do you ultimately go with? But also as a developer, where should things like state management go? Is that the responsibility of an MCP server developer, the backend, or is it the responsibility of an MCP client? And there's that paradigm brings up a lot of questions. And it's not very different than the days of APIs. Do you put logic in the front end because you want to control it?
Yeah, this is server-side rendering versus client-side. And ultimately, it can be a lot more destructive So we have to think about how do we rein these in? Where does the logic go? How does especially, like, I guess what you said with sampling, right, where you can be on the hook for computation and
Right.
supplying extra details. You have to know, okay, well, what could, if I receive as a MCP client a sampling request, what am I sending back? And
does your MCP client have access locally to tools? Can it then
sure,
use them as part of a
servers.
request from an MCP server?
Because I guess a malicious MCP server could say, what other tools do you have access to? Go find out for me and tell me.
And these are all things I think the protocol and developers and a standardization about where certain functionality should live, and then how we follow that is what we're still discovering. And the maturity, and back to my original statement of the promise of MCP could take us. So right now I'm still excited about the promise. I'm waiting for, as a friend of mine says, Keenan, he says, he likes the protocol. And I agree with him. There's a lot in there that's exciting. It will come down to how's it implemented.
Well, this stuff's only, 4 months old at this point.
Right.
So we'll have to find out.
Indeed.
All right. Last question, I think. Where do you see this in a year in terms of AI? What do you think is going to be our conversation 1 year from now? And I guess also part two, what about 5 years?
5 years, I'm not sure I can answer that question. But 1 year, I hope that we have a set of evolved tools that allow us to go past the concept of how should you make an agent and manifest it, and how should you orchestrate a collection of agents in a pattern to do something. I hope that we get a better grip around those concepts in the next year, so that we can then go to where my mind wanders, which is how do we then start to work on concepts like optimization and automation, and start giving, within constraints and some boundaries, agents more flexibility in writing and doing code gen, and developing approaches to solutions that are optimized and self-learning and self-correcting, so that we can then start to focus on tasks and challenges and problem spaces more, rather than how do we implement it.
It makes a lot of sense. And AI coding does feel magic, but there are times when it's also phenomenally like, no, this is not what I asked for. This is a really stupid approach to this. And being able to control this incredible force that can sometimes do really bad things, and if you don't rein it in, can do destructive things, but figure out how do we use it for productive solutions, and how do we constrain it properly so that it can safely do more and more advanced things.
In that interim, in how we get there, that journey, there's value in that journey as well. You mentioned something just now that is colloquially known as like vibe coding, where you just jump into cursor and you say, write this function that does X. And you wait for cursor using Claude or something to give you a bunch of code, and you just basically kind of look at it and then wink and squint and, okay, yeah, let's keep going. Well, there's value in that, though, because sometimes those approaches, even though they're just way off or just overly verbose or not very elegant, they can generate thought and conversation and introspection about, oh, I hadn't thought about maybe approaching it this way. And I think that's what's going to happen along the self-optimizing agents and orchestrations, is that they may not always be right, but they're going to help us understand and explore the surface of how to go about solving complex problems.
And just changing the internal cost of that equation, right? Because I think as programmers, you still think, how do I write a program to do this that I never have to touch it again? Mm-hmm. But with an AI, you can just say, I don't need a permanent solution that I can ship and then never have to deal with again. But I get the AI to deal with it right now and kind of kick the can down the road. And maybe, by the time you catch up to the can, AI is 10 times cheaper and 10 times smarter, and you won't have to worry about it.
I think that's possible. I see it right now as like when you and I are together and we are hacking and pair programming. I appreciate having other perspectives on a problem where I can go, no, I really like my way of doing it, or no, I think, Stephen, you've got the way to do this, and I should have thought about that. I'm just being stupid. I think AI will help us along journeys in that similar way, where they'll challenge us. We will either agree with them or experience a new way of looking at a problem, or we'll at least be validated and more cemented in our understanding of a problem and how to best approach and solve it. I hope we don't do too much of the technical debt, kicking it down the road with the hope and promise that things will just solve it in the future, because that's sometimes how we've ended up in messes in programming historically.
Well, I think with that, how do people find you? How do people get more David Hughes?
Well, I recently have started, and thank you for asking, Stephen. Recently have started a new blogging site on what I think is an evolving, very immature, but someday going to be very important approach to how we think about data, and that is something called hyperdimensional computing. So if you want to follow me and see where my mind is wandering on the topic, you can go to hyperdimensionalcomputing.ai.
All right, put it on a banner right there. Link in the description.
Awesome.
Check out hyperdimensionalcomputing.ai. David, thank you for visiting the AWS Made Easy Studios, and we will see you next time.
It's always my pleasure,
Thanks a lot.
Stephen. Thank you.
Another week, another CloudFix Finder Fixer.
This one is an easy one.
RDS IO1, IO2 to GP3 volumes. What I really like about this Finder Fixer is building on existing expertise.
You have a finder that goes and finds all the instances where you can switch to a much more cost-effective option.
We'll look at CloudWatch metrics, we'll look at the performance of the drive. If you're not really working it that hard, then why pay that price? Now, the innovation this week, we can do that for RDS volumes.
I completely understand production workloads. You want to optimize production workloads as much as possible.
When you need that blazing fast throughput, very low latency.
Makes sense. In dev environments, absolutely doesn't. Developers deploy IO1 and IO2 volumes with their RDS instances. When was the last time you really pushed the limits of an IO1 or IO2 volume to that level of throughput on a dev instance when you're doing a bug fix? I don't see that happening. About the difference between sub-millisecond and about a millisecond, right?
The equivalent of a Ferrari versus a minivan.
What's the retail on one of those?
More than you can afford, pal. Ferrari.
You don't want to be using this. It's an order of magnitude more expensive.
In terms of counts, you typically find dev and staging contributing to about 80% of the database instances within an organization. Production only accounts for about 20% of the number of instances. They are larger, they are bigger, they are more expensive. But in terms of count, dev and staging dominate.
Yeah, there's UAT, test, staging.
For every one database in production, you probably have 10 databases in other environments that don't need remotely as much throughput or latency as what you have in production.
It's fun to use the fastest thing. It's not fun to pay for it. You want to make sure that you're only paying for it if you really need it. For the situations where you don't, where you'd be better served with something that costs, like I said, a tenth the price, take that option. And with CloudFix, with this new Finder Fixer, we will make it easy. It detects it, and then you just need to click that execute button. You're good to go.
I am really excited about this.
If you want to free up that budget, what better way to do it than to not pay for over-provisioned EBS volume?
There are better places to spend money if you absolutely want to spend money.
Go play with SageMaker, go play with Bedrock, add AI to whatever you're doing. That's a really fun use of that fund.
If you're running out of ideas, join our other live stream where we talk about AI ideas that we've been implementing with Bedrock and other tools. We have a lot of amazing stuff planned out for the next few weeks, so stay tuned.